Hello everyone, welcome to Geeky Nerd. Today we will begin with the part 2 video of time, speed and distance. Before moving into the video, I hope everyone would have become thorough with the basics. If you have not seen the part 1 video, click on the card or the link in the bio to watch it. In this video, we will be discussing how time, speed and distance are interrelated with each other when any one of the three remains constant. Like, share, and subscribe the channel for more interesting concepts and shortcut methods for solving them. Without wasting any time, let us head into the part 2 video of time, speed, and distance. In this concept, we will see how two of the three entities, that is speed, distance and time, are related with each other when any one of them remains constant. There are three cases in this concept. As per the first case, when distances d1 and d2 remain the same, speed becomes inversely proportional to time taken. So here we are considering two different journeys. We are said that the distance covered in both the journeys remain the same. Therefore, when the distance covered in both the journeys remain the same, the speed becomes inversely proportional to time taken. That is, speed is equal to 1 by time, and it can also be written as S1T1 is equal to S2T2 till SNTN. Therefore, there can be n journeys. When the distance covered remains the same for n journeys, then the speed of each journey is inversely proportional to the time taken during the journey. In the second case, speeds of both the journeys S1 and S2 remains constant. In such cases, distance of the individual journeys becomes directly proportional to their individual time taken. That is, when S1 and S2 remain equal, then d1 by t1 is equal to d2 by d2 and equal to d3 by t3 and so on. In the third case, when time t1 and t2 remain the same, then distance covered by the individual journeys becomes directly proportional to the individual speeds. That is, d1 by s1 is equal to d2 by s2 is equal to d3 by s3 and so on. In all the three cases, we came across that any one of the three entities remain constant, whereas the other two entities are inversely or directly related to each other. Let us solve some examples to understand this concept. A person covers a distance of 12 km while walking at a speed of 4 km per hour. How much distance he would cover at the same time if he walks at a speed of 6 km per hour? So from the question, we can easily identify that time remains constant. It has been given as same time for both the journeys, hence time remains constant. From the concept, we know that when t remains constant, then distance becomes directly proportional to speed. That is, d1 by s1 is equal to d2 by s2. We know d1 is equal to 12 km, d2 is what we have to find, and S1 is equal to 4 km per hour. S2 is equal to 6 km per hour. By substituting the known values in the formula, we get 12 by 4 is equal to d2 by 6, which implies d2 is equal to 12 into 6 by 4, which is equal to 18 kilometers. So, if a person covers a distance of 12 km walking at a speed of 4 km per hour, he can cover 18 kilometers if he walks at 6 km per hour, provided that the time remains constant for both the journeys. When time remains constant for multiple journeys, then distance becomes directly proportional to the speed as we discussed in the concept. let us solve one more problem. Two men start together to walk a certain distance, one at 4 km per hour and another at 3 km per hour. The former arrives half an hour before the latter. Find the distance. So from the question, it is clear that distance remains constant. Therefore, we know when d remains constant, then speed is inversely proportional to time. That is, or S1 is equal to 1 by T1 or S1 T1 is equal to S2 T2. From the question, we know that S1 is equal to 4 km per hour, S2 is equal to 3 km per hour, and we know that time T1, T2. Here T2 is given in relation with T1, that is T1 arrives half an hour before the latter. Therefore, if we assume T2 as capital T, then T1 is equal to T minus half. That is T1, that is the first vehicle, first man, arrives half an hour before the second man. Substituting the known values in the formula, we get S1 is 4 multiplied by T1 will give T minus half, which is equal to S2 is 3 multiplied by T. Upon solving, we get twice of 2T minus 1 is equal to 3T. 4T minus 2 equal to 3T, which implies T equal to 2 hours. So we found out that the time taken for the journeys is 2 hours. Second journey will be 2 hours and first journey will be 1.5 hours. Now we need to find distance. Distance is equal to speed into time, which is equal to S1 T1, and substituting we get S1 is 4 km per hour multiplied by T1, which is equivalent to 1.5 hours. This is which is equivalent to T2. Therefore, T1 is equal to T2 minus half an hour. Therefore, 1.5, which will give us 6 kilometers. Thus, we solved the first problem where the time remained constant and the second problem where the distance remains constant. Thus, using this concept, if any one entity remains constant, then the other two entities can be related with each other either directly or inversely depending upon the constant entity. Through this video, we learned the relationship between time, speed, and distance when any one of the three remains constant. Problems were solved via shortcuts and traditional methods. Viewers can choose any method depending upon their convenience. I insist all the listeners to practice solving more and more problems to increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can be benefited. Until we meet in the next video, thank you.